may be full wave rectifier or bridge rectifier. We know what is the average output voltage formula. The average output voltage V naught equal to 2 Vm by pi cos alpha with assumption of continuous mode students. Okay, this is the average output voltage formula. In most of the practical applications we are preferring the continuous mode only, that is why we are considering this formula. In a single phase full wave or fully controlled, it may be bridge rectifier or midpoint type rectifier, V naught equal to 2 Vm by pi cos alpha. What the range of firing angle students? The range of firing angle is that is 0 less than alpha less than 180. For any firing angle in between 0 to 180 degrees, you check what is the polarity of voltage and current. See, for alpha less than 90 degrees, means that is for 0 less than alpha less than 90. You substitute any firing angle in between 0 to 90 degrees students. Substitute 30 degrees, 60 degrees, 40 degrees, any firing angle you have to substitute, then we can get V naught is positive. V naught is positive. But I told already, in rectifiers the current is always positive, current never be negative. See, for example, let us consider this is the full wave rectifier. If you have to consider the any full wave rectifier, better to write here. Let us consider a full wave rectifier. I am explaining. I am taking the bridge rectifier. Why the current is always positive, that you will see. You take any load. Yes friends. See, always the current is this direction. Current is negative means current must flow this direction. Current must flow this direction. Then only current is negative. But the devices cannot allow in the reverse direction. The thyristors cannot allow in the reverse direction. This is wrong. That is the reason why in rectifiers the current never be negative. But in dual converter current is negative. But in half wave rectifier or full wave rectifier students, the current never be negative. The current is never negative means why? The thyristor cannot allow in the reverse direction, then always current is positive. Any firing angle always current is positive, that you have to concentrate. That is for alpha less than 90 degrees, V naught is positive and I naught is always positive. V naught positive, I naught positive students, which quadrant? It is the first quadrant. For alpha less than 90 degrees, this converter is operated in the first quadrant. If you take alpha greater than 90 degrees students, you take alpha greater than 90 degrees. Alpha greater than 90 degrees means 90 less than alpha less than 180. 90 less than alpha less than 180. You substitute any firing angle between 90 to 180 degree, this becomes negative, cos 120 minus 1 by 2. This goes to negative. That is V naught is negative. For alpha greater than 90 degrees, we are getting V naught is negative. But what about I naught? I naught is positive. V naught negative, I naught positive students. V always current is positive. The current never be allowed in the reverse direction in the rectifiers. V naught negative, I naught positive means which quadrant? Fourth quadrant. V naught negative, I naught positive means it is the fourth quadrant. That is the reason why this full wave rectifier is operated in the two quadrant, first and fourth quadrant. Hence, A single phase full wave rectifier, it may be midpoint type rectifier or it may be bridge rectifier. It is a 2 quadrant converter and it is also 2 pulse converter, that already you know. Therefore, a single phase full wave rectifier or fully controlled rectifier is a 2 pulse, yes friends, 2 pulse and 2 quadrant converter, 2 quadrant converter, 2 quadrant, that which quadrant? First and fourth quadrant, first and fourth quadrant, 2 quadrant converter. It is a 2 pulse and 2 quadrant converter, friends. A single phase full wave rectifier is a 2 pulse and it is a 2 quadrant, which quadrant? First and fourth quadrant. Now if you represent the quadrant operation, and before that one more observation here, friends, that you have to concentrate. If you take for alpha equal to 90 degrees, in this if you substitute alpha 90 degrees here, all this I am substituting here, V naught equal to Vm by pi cos alpha na. This is the average output voltage of full wave rectifier, it may be midpoint or bridge rectifier. Substitute alpha equal 90 degrees here, cos 90 is 0, that is V naught is 0. V naught 0 means for alpha equal 90 degrees, neither first quadrant nor fourth quadrant. It is not operate in the first quadrant, it is not operate in the fourth quadrant. Okay, that is for alpha equal to 90 degrees, the V naught equal to 0. Now if you have to represent the what is the quadrant operation, students, that you have to concentrate. If you represent the quadrant operation, yes, it is operating in the first and fourth quadrant. It is operated in the first and fourth quadrant. It is operated in the first and fourth quadrant. Yes. For alpha less than 90 degrees, for alpha less than 90 degrees, it is operated in the first quadrant, alpha less than 90 degrees. Then V naught is positive, I naught is positive, V naught is positive, I naught positive. V naught positive and I naught positive means that is V naught greater than 0 and I naught greater than 0. For alpha greater than 90 degrees, for alpha greater than 90 degrees, students, V naught is negative, I naught is positive, V naught is negative, I naught is positive. That is for alpha greater, this is also, this type of options also giving in competitive exam, V naught less than 0, I naught greater than 0. Okay, this is quadrant operation, this is the first quadrant and this is the fourth quadrant operation. Now we will see observation here. For alpha equal to 90 degrees, this indicates alpha equal to 90 degrees, students. This is for alpha equal to 90 degrees. This is for alpha equal to 90 degrees, V naught is 0. That means alpha equal to 90 degrees is the boundary between the first and fourth quadrant. It is a boundary between the first and fourth quadrant. And it is the boundary between the forward motoring and reverse braking. Why it is a forward motoring, why it is a reverse braking, that I will explain. Yes, see the students. For alpha less than 90 degrees, V naught positive, I naught positive. For alpha less than 90 degrees, V naught positive, I naught positive, power is positive. Power is positive means conventional power direction, power is delivered from source to load, source to load. Power is delivering from source to load means then it is used for which application? Motoring mode. That motoring mode is nothing but a forward motoring mode. Okay, this I am writing here. These statements are important, students. For alpha less than 90 degrees, for alpha less than 90 degrees, that is for 0 less than alpha less than 90. V naught positive, V naught positive, I naught positive. Yes, students, power is positive. Then power is delivered from source to load, source to load, source to load. Yes friends, power is delivering from source to load. In rectifiers, source is AC, load is DC in rectifiers. That is, power is delivering from AC to DC, hence it is rectifying mode. Hence it is rectifying mode, rectifying mode. Yes friends, why it is a rectifying mode? The power is delivering from AC to DC, rectifying mode, and it is used only for forward motoring control, and it is used for forward motoring control, and it is used for forward motoring control, FM control, and it is used only for forward and it is used for forward motoring control for alpha less than 90 degrees. That means for alpha less than 90 degrees friends, for alpha less than 90 degrees, this is forward motoring mode. It is used for forward motoring control. This is FM. Then this is which mode? It is a rectifying mode. Rectifying mode. Rectifying mode. Yes, FM stands for forward motoring control. This is FM stands for forward motoring control. Rectifying mode. In first quadrant, it is operated in which mode? Rectifying mode. Okay, that you have to concentrate. I am using this color. Yes, to use this. Yeah. It is used in which mode? Forward motoring mode. For alpha less than 90 degrees. For alpha less than 90 degrees. Yes friends. What about for alpha greater than 90 degrees? See this one. Just a minute. Yes friends, see for alpha greater than 90 degrees, what is the observation? For alpha greater than 90 degrees, for alpha greater than 90 degrees, what is the V naught you got? V naught is negative, I naught is positive. V naught negative, I naught positive means what the power students? Power is negative. Power negative means opposite to the conventional power direction, then power is delivered from load to source. Power is delivered from load to source. Delivered from load to source. In rectifiers, load is DC always, source is AC. Power is delivering from DC to AC, hence it is inverting mode. Inverting mode. For alpha greater than 90 degrees, it is invert. Alpha greater than 90 degrees means 90 less than alpha less than 180. Inverting mode. This inverter, actually it is not an inverter circuit, it is operating as an inverter. These inverters are called these inverters are called, yes friends, are called line commutated inverters. Line commutated inverter. Actually it is not an inverter circuit, it is a rectifier circuit, but it is operating as an inverter because power is delivering from load to source. Power is delivering from load to source, that is DC to AC, that is why it is an inverter. Operation as a inverter, and these inverters are called line commutated inverter because in rectifiers what type of commutation we can use? Line commutation or natural commutation, that is why it is called line commutated inverter. Then for alpha greater than 90 degrees, power is delivering from load to source, and these inverters are called line commutated inverter. Therefore, for alpha greater than 90 degrees, it is used for, then for alpha greater than 90 degrees, alpha greater than 90, it is used for reverse braking mode. Reverse braking mode control. Reverse braking mode control. Okay. This is reverse braking mode control we can use. This representing as a RB, reverse braking mode we can use. Okay. This is for alpha greater than 90. This you see in axis representation. For alpha greater than 90 degrees, for alpha greater than 90 degrees, it is used in reverse braking, and it is which one? Inverting mode. This is which one? Inverting mode. Alpha greater than 90 degrees, it is a inverting mode, and it is used for reverse braking control. It is used for which control, students? Reverse braking control. Reverse braking control. But this is corresponding to alpha equal to 90 degrees. This axis is corresponding to alpha equal to 90 degrees. For alpha equal to 90 degrees, if you see for alpha equal to 90 degrees, better to write in the next slide. Next, for alpha equal to 90 degrees, V naught is 0, then it neither operate forward motoring, neither reverse braking, neither forward motoring nor reverse braking, neither forward motoring nor reverse braking, and it is boundary between forward motoring and reverse braking, students. Forward motoring and reverse braking. Okay, this is the boundary between forward motoring and alpha equal 90 degrees is the boundary. Okay, that point mainly how to concentrate. Yes. See the one more observation, students, here. If you draw the control characteristics of full wave rectifier, okay, what exactly line commutated inverter, that is important. For alpha greater than 90 degrees, power is delivering from DC to AC, load to source. Power is delivered from load to source, and hence it is inverting mode. These inverters are called which inverters, students? Line commutated inverters. That is very important observation. If you see the control characteristics of, if you draw the control characteristics of full wave rectifier, control characteristics of single phase full wave rectifier or fully controlled rectifier, for both midpoint and bridge it is applicable. If you see the control characteristics, what is the V naught, students? This V naught equal to 2 Vm by pi cos alpha. V naught equal to 2 Vm by pi cos alpha. Correct? This V naught equal to Vm by pi cos alpha. This is V naught. Yes, I am writing this. V naught equal to Vm by pi cos alpha. If you substitute alpha equal to 0 degrees, what is V naught? 2 Vm by pi. Okay, this is the maximum average output voltage. For alpha equal to 90 degrees, what is V naught? 0. For alpha equal to 180 degrees, what is V naught? Minus 2 Vm by pi. This is the negative maximum value. That is, if the firing angle is controlled from 0 to 180 degrees, okay, this is V naught, alpha equal to 0 degrees, alpha equal to 90 degrees, alpha equal to 180 degrees. That is, if alpha is controlled from 0 degrees to 180 degrees, then what are the average output voltage? The average output voltage is controlled from 2 Vm by pi to minus 2 Vm by pi. That positive to negative it is controlled. Then if you draw the control characteristics for this case, if you draw the control characteristics, friends, then what the control characteristics we can get, that you have to concentrate. For different firing angles, if you draw the control characteristics, that I am drawing here. Yes. See, for alpha equal to 0 degrees, this I taken alpha, this I taken V naught. V naught is taken, and this is, yes. For alpha equal to 0 degree, this is for 30, this is for 60, this for 90, 120, 150, 180. Yes, friends. For alpha equal to 0 degrees, it is 2 Vm by pi. 2 Vm by pi. Alpha equal to 90 degrees, it is 0. Then here I am drawing the characteristics. We can get, it is changing from 2 Vm by pi to, it is change, the characteristics are like this, we are getting 2 Vm by pi to minus 2 Vm by pi. It is 2 Vm by pi to minus 2 Vm by pi we are getting. Okay, these are the characteristics. This is for alpha equal to 180 degrees. This is how much? Minus 2 Vm by pi. Students, if alpha is controlled from 0 to 180 degrees, for alpha equal to 0 degrees 2 Vm by pi, alpha equal to 180 degrees minus 2 Vm by pi. Okay, these are the control characteristics of, yes, these are the control characteristics of, this is a single phase full wave, both the cases for both midpoint and bridge it is applicable. Okay, this is for alpha less than 90 degrees, this is for alpha greater than 90 degrees. Alpha less than, this is in which mode? Forward motoring mode, and this is for reverse braking mode. This is the boundary, this is the boundary between forward motoring and reverse braking mode that you have to concentrate. Okay, this is a control characteristics.